Well, welcome to my channel Mispronounced Adventures and welcome to a van tech video. This one's working with VELIT. So quite often in the winter months I bang on about diesel heaters a lot. Diesel heater. For the heat, I said heater. Leave the heating on. I did turn the heating on in the van about an hour ago. But I'm not looking at diesel heaters for once, I'm working with VELIT, who I have also looked at their diesel heaters in the past. But this time it's the summer and it's been hot in the UK. And they've offered me to look at their air conditioner, the VELIT 2000U, which is a underbench air conditioning unit. So, as normal, unbox it, do some technical tests, see how much power it uses and have a look at the unit, and we'll go from there. Well, I feel this is going to be quite awkward to open. Packaging! Okay, there's already a lot going on here, we're going to get the camera. Right, in the box we've got power supply cable. This is a 12 volt air conditioner, so it is not running off AC as an alternating current. It is DC, so it can run directly off your batteries. And we'll check out the specs when we have everything unpacked. Ducting, as it is an underbench style one, it's designed to be ducted around the vehicle. Big vent adapters, another big vent adapter. So this unit, there are a few other styles of underbench units which have holes in the bottom of it, and then you drill holes at the bottom of your vehicle, which is great for some models of vehicle. Vans, it's a little bit less convenient because those holes are in fixed positions, which means if you've got a chassis member in the way, you can't drill through it. I believe this one ducts out the side, so then you can run this, I guess, through the floor if you wanted, or out the side of the van. And then, woo, that was the vent covers. Two of those, big Jubilees. A box, we'll open that in a moment. Templates for all the mounting aspects, that's quite nice to do. Right, and the unit itself. This might take a bit of effort to get out the box. I wonder if I can just put it down there. Yeah. There we go. Let's tidy up the box a bit. Oh, there we go. Example of how you can install it. Straight out, going down for the vent tubes. These ones are the sort of the intake and the exhaust for the compressor side. To make cold air out one side, which is sucking in and cooling your internal air, you need to be able to suck in fresh air to cool the compressor. Making cold air makes heat. It also comes with mounting brackets as well. And the material it comes on is, because it's just insulated, feels a lot like polystyrene, although it feels a lot tougher than that. Spin it around the other side. The other side, your airflow out, your control panel, and that means you're going to have to mount it in somewhere where you can see the control panel and air can get sucked in easily. Drainage hole, because making water does make condensation from time to time, and then these mounting straps, which we'll have a look at in a minute. Before we get on to the next bit, let's see what's inside the box. Oh, okay. So there's a control panel on the unit, and there is also a control panel you can go mount wherever you want. Manual, remote control as well, because you don't want to have to always reach up and turn something on and off. More Jubilee clips, most likely for the ducting. A back box for control panel if you're going to mount it somewhere. Heavy duty brackets, so for mounting the unit to the floor. Variety of fixings, stainless steel, self tappers, long, short, and an elbow for the water. Cable management, and then the wire for running the control panel as well. The other bit I want to look at is cabling. I don't always like pre-made cabling which comes with units because often the quality is not great. But it's in conduit. It looks like 16mm squared. Well, it says on the lug that it's 16mm squared. And it's got 3 fuse holders in it, I'm going to assume. So these fuse holders are just 120 amp fuse, which I think is likely just acting as the way of connecting the tails to either end. And then another positive 120 amp fuse at the other end. If it's a 16mm, 120 amp is probably a little bit on the high side. I'd probably want to see 80, but I guess we'll find out when we actually test the unit. Specs as I can see for that, I've got the 12 volt version. There's also 24 and 48. I kind of want to have it apart to see what actually is the 12 bit and how they make all the different variants. 8000 BTU, so 2200 watt cooling. This is going to run up to around 20 to 60 amp, and that's the refrigerant, how much refrigerant it uses. Just so people are aware, cooling watts is different than electrical watts. Electrical watts is significantly lower. Simply put, cooling watts is the amount of watts as an energy you remove from the air to cool, whilst electrical watts is the amount of watts electrical you're using to do that. I'm going to have a little look inside the unit as well. Speaking of looking inside the unit, I wonder if we can just undo the straps and if the top just comes off. It kind of feels like that is going to be the case. I'm really hoping this is not going to turn into one of those things which was far simpler to pull apart. Well, there we go. Let's just take that one off there as well. So looking at it just taken apart, the actual casing is in is also a lot of the housing. It is the air runs, and there's also the chassis mounts for things like the motors as well. Apologies to the HVAC engineers, as I'm about to use the words radiator. I should have used evaporator and condenser coils, or maybe even heat exchanger. Radiators are traditionally for, while similar, but more vehicle format. So 2 sets of fans, 2 sets of radiators. One is going to be hot to cold, one is going to be cold to hot. Compressor, I'm guessing speed controller or the compressor driver, and some sort of buck converter down there, which we'll have a look at in a minute. The actual motors themselves are housed in the polystyrene-like material which holds everything together. I mean, I can see there's already some bent over fins and stuff, which just might be from how this unit gets put together on the top edges, which are the most exposed. On the fans themselves, there's been some balancing done because it's got little markers on it in different positions. And motors have 4 sets of wires going for them. So they are brushless motors, so you've got positive and negative, PWM for speed control, and then promise some sort of feedback for RPM. Temperature sensor, ducting unit. So underneath this edge is where the plugs go for the additional controller, which you can run the cables out here. Weight, and this is the main compressor itself. Now the bit which particularly interests me is this unit and what makes it 12 volt, 24 volt, or 48 volt. Let's have a look, see what we've got. Okay, looking closely, it does seem, looking at the compressor itself, is a 12 volt compressor, as is this, which I'm guessing is the speed controller. It's an inverter based compressor, which means opposed to a traditional compressor which will be on or off, an inverter based one can adjust its speed to the cooling demand. I still want to know what the buck boost down there is for though. I'm not going to know because it's glued down, so I can't actually tell you. That's annoying. I mean, that bolt looks a bit loose. I know these are shock absorbing for the compressor, but that should be on a little bit more, just enough to put a bit of tension on it, just like all the other ones. I could also see a couple of temperature sensors, one on the evaporator side, bit which is the cold air, and around the front of it looks like to be the ambient air temperature, which is going to be what the automatic thermostats are using. Well then, let's just put it back together and get it fired up. Right, let's set the unit up and just get it turned on for the first time before we start doing some proper testing on it. Right, that's that one done. Let's get the unit turned around. Right, for testing purposes, I need a battery. So I've got a brand new Roma Smart 4 105 12 volt, which is one I've just borrowed from work. Now, thing to point out for running aircon off-grid is it's not about a really high power draw, although they do use quite a bit of energy. It's about you're running it for a long time. So from a testing purpose, this small battery is going to be plenty enough to run the unit. For long term, for actually using it practically off-grid, you want a pretty substantial battery bank to be able to run it off-grid or to be on hookup. The main reason I'm using the Roma battery is, one, I work for them, so I can just borrow it from work, and two, we have a really cool app which shows you all the amps and watt readings and all that information, which is what I want to sort of measure how much power this is using. So let's get it connected up. There you go, you haven't seen a Roma battery before. We've got our 3 connectors on it. That's connected to other batteries. That connects directly to the Victron system, or Saphir Marine system, or Saphir system, or quite a few different systems that just plug and play CAN bus integration. Not on yet because the battery's not turned on, so let's just turn it on. There we go, it's booted up. Let's actually put the remote control on. You could have provided me with batteries. Who doesn't love a stuff drawer? Pretty comprehensive guide how to install. So you know what, let's just turn it on. Okay, these batteries don't actually seem to work, so let's go get some batteries. Well, it's a few hours later, and I thought I would just set it up and get it running. So as I showed earlier, the aircon unit is meant to have ducting running out the window, or ducting running through it. Obviously you don't want to put heat from the compressor into the area you're trying to cool, so let's run it out the window temporarily. Probably work. There's one. These are directional, and it does show in the manual that if you're going to have them next to each other, have them pointed either away or out like that, just so the air is being pushed in different areas and you're not sucking hot exhaust heated air back in to cool the compressor. Oh, it's mounted. Right, all set up. I have the Roma app here mainly so I can just see sort of the wattage and the amps the battery's using. It is currently ambitation 27 degrees in here, which is about right. It's quite warm. So what I want to do is run this and see how long it takes to get down to, I don't know, 20 degrees. I've not really played with it properly yet, so I'm just going to turn it on and set it to cool. We're going to set it to 20 degrees. And I'm just going to leave it to it really and come back and whenever it's there. So it's currently 1740. It's really pumping out some cool air. And straight off the bat, it's currently using 28 amps. But we'll have some proper testing later on of the different eco modes and turbo modes. And to quickly bring the thermal camera, giving out 15 degree air, or 14 degree air on that one. And the ducting at the back is heating up. Let's see what the ducting is like. And the external ducting you can clearly see is working. Externally, not very noisy. Let's put on some of the ducting so we get a bit more of an even distribution between the vehicle. And still pulling 35. Ducting is dropping, now about 11 degrees. Right, I think we'll leave it and then come back when it's run for a while. Oops, I forgot that I needed to pump the drain valve somewhere. And it's used, well, it's currently on 18.5 amp at 12 volt. It'd be interesting when we play the settings properly to figure out why it's gone to 18 amp and it's not on the higher settings of 30 amp, which I saw earlier, even higher, where it says up to 60 amp. But this was just to test it, and it has certainly got cooler in here. Logging into the servo, you can see the temperature inside the habitation dropped. I think it plateaued there when I opened the door and left, and it's kind of drop again. So it's working pretty well. I think what I just want to see next, quickly before I turn it off, is I want to hit the turbo button. So this is the generic controller it comes with. Now it does say, now some of the buttons like heat don't do anything, but I want to hit turbo and see what happens to the amount of power. Nothing. Oh no, now it's changed to turbo mode. There's a light change on there. I can hear a rumble. And it's gone up to 33 amps, so we'll leave it running for a bit longer. Right, I thought we'd just pull out the camera again. The thermal camera at least. Definitely dropped a bit, and you can hear the compressor working a little bit harder, but not much. Right, let's turn it off, and we'll properly test some of the other modes later. So it says on the website, it will make up to 15 litres of water in dehumidifier mode. That was just in my hour test, which is why it's probably important to have the drain running. Although the website does say it produces 15 litres of water, for your off-grid needs, please do not drink air conditioner condenser water. It is demineralised. As much as I want it to be, this is not the occasion to fulfil your Star Wars fantasies to be a moisture farmer on Tatooine. Right, there's plenty of other buttons on the controller, so you can get it to show voltage with the squiggle button. That display turns the display on and off. As said before, a bunch of the other buttons don't actually do anything. You can get it also to display the actual temperature that the unit itself is reading. I just don't always know how. It seems to do it if the unit is powered up but not actually doing any cooling. And also the controller interface you've got to mount on the wall somewhere. Not much has changed. Generally the same interface as the unit itself. And here's a quick look at the back just so you can see where the wires go. So we're about a week later from the last bit of footage and it's time to test. So I want to look at power consumption, not so much the cooling itself, but I want to run it on all the 4 different modes. So normal cool, where you have the target temperature, eco mode, sleep mode, turbo mode, and just look at the different power consumption in all of them. And again, I'm going to use the Roma app to show what's going on and a bit of thermal camera to sort of show if there are any temperature differences. There also will be a bit of audio difference as well. The other variable is on the fan speed, there is an auto setting, so I'm going to run it on auto, so hopefully that just change it to the correct fan speed for whatever mode we've got it set on. So at the start, currently using 4 watts. Turn it on, let's turn it to auto mode. Currently set to minimum, and let's let it go. Hear the compressor firing up. And let's leave it for about 5 minutes running on each mode. 2 minutes in, about 27 amp and 340 watt. Temperature is starting to drop. Ambient outside is 23 degrees and inside is 13 degrees. About 5 minutes in, and the compressor has just dropped down to using 20 amp and rising again. And the temperature in the outflow is about 9 degrees, or 8 higher up. Well, let's come back in about 10 minutes and see what it's doing. Right, we are about 10 minutes in and it's currently pulling 30, well it was pulling 30, it's dropping down again. It seems to cycle up and down quite a lot. Let's run the thermal again. So now we've got a 6 degrees output air. And it's risen back up to 30 amp out. Right, I'm probably going to leave it maybe 20 minutes, just run in and see what it's doing. Well, it's certainly starting to drop in here. It's now 19 degrees. It was 23 when I started. So we are about half an hour later and rising again. About 25 amp still pulling, 320 watt. And on the thermal, about 5 degrees. Right, well it's now shot back up to 31 and then dropping down again. Well, let's put it onto the next mode and see where it goes from there. So now dropping it onto eco mode. About 25, not much has changed, but we'll leave it for a few minutes. Right, well we're back after about 10 minutes on the eco test and it's still pulling 24 amp. Quick on the thermal, still pretty similar at 6 degrees. Well, so far the main characteristic change for eco mode is it's not rising up to 30 amp, it's staying around 25. But the unit is rated to 60 amp, so I guess 24 is less than half of that. That could be seen as eco. Next up, sleep mode. So the noise immediately changed and it's dropped down to 18 amp. By noise I mean the compressor side is dialed down to a lower setting. The actual wind that you can normally hear from the vents on the camera is about the same. So a few minutes into running it and the out temperature has already started to rise from that 6 degrees to about 8.2 degrees. But it makes sense, it's using slightly less power, so it's gone slightly up. The fan is still quite noisy though. Right, I've just turned the fan from auto down to setting 1 and it's significantly more quiet, which is no surprise. And it's also dropped to about 15 amp. Right, I've just turned the thermostat up to 21 degrees, which is slightly warmer than it currently is. The fan stayed on a bit, but I think the compressor is actually turned off. Yeah. Observation quite quickly on the automatic mode for the fan speed. It's playing around the temperature settings. So even though it's on the eco mode or the sleep mode, it's still trying to reach its target temperature. So on auto fan, if you're far away from your target temperature, then the fans are on higher. And it seems as you approach your target temperature, then the fan decreases until you hit it and then the unit turns off. Right, turn us off for a minute because you need to go do some other work and then come back and we'll test the rest of sleep mode and turbo mode. Right, it's back on again, running on sleep mode and it's currently pulling 15 amp. Next up, turbo mode. Right, we're back about 15-20 minutes later running on turbo mode. Currently it's cycling up and down, so I did just see 37 amp and it's just dropped down to about 18 and now rising again. And then dropping again. So one of the things VELIT did say when I did some off-camera testing and I couldn't really get it to do anywhere near 60 amp, about mid-30s was the highest, was that it's only going to get those peak 60 amp output if it really needs it. At the minute it's pretty close to its target temperature. It's about 19 degrees in here, this is set to 16, so let's turn the diesel heater on and get it really warm in here and see if I can get the full 60 amp rating out of it. I'm going to go with 37. Right, let's come back in 10 minutes, hopefully when the diesel heater is booted up. Right, been going for about 20 minutes with the heater on. It's now gone up to 42 amp, 500 watts. Let's see if we can carry on and get it up to the 60. Right, we've got 13 degrees there. 100 degrees coming off the diesel heater. 30 degrees there, and it's 44 amp, 45. Right, let's see if I can crank it up another level. Another heater on. Right, I pointed the heater directly at the temperature sensor on the unit. We're out to 47. 600 watt, 49. 50 amp. 51 amp. I think I'm probably about to run out of power before this gets up to its target. Right, I think I actually need to go charge this before we can try and max it out again at 60 amp. Right, I'm back. Battery is charged enough for what I want with the testing. It's now 40 degrees in the van because I've got the diesel heater and this on max. So let's boot this back up and see if we can get it to hit that 60 amp that it's rated for. And here we go. Oh, we have an error. What is the error? E6. Well, E6 is apparently an over voltage error and it's only 13 volts. So we'll just turn it off and on again and see if that fixes it. There we go, the compressor's fired up now. I don't know why that caused that error that time around. Go straight up to 34. Kind of positioned the hot air right on where the temperature sensor is, so hopefully that can get it hot. Climbing, we're at 38, 40, 41. Heater itself is working hard. 42, 24 degrees coming out with, in parts, 55 going in. 45 we're climbing, 47, 49 and 640 watt, 50 amp, 660 watt. Now whilst the current rating is 60 amp, the maximum power rating is apparently 700 watts. So let's see which we get there first. We will reach the wattage long before we reach the 60 amp. 20 degrees going out, 47 degrees on the ducting. 670 watt, 680 watts, 685, 52.3, 688, 690, 691, I saw 693 a second ago. Oh, 699, 700 watts! And the exhaust on the outside is 47 degrees. Well, it hit the target 700 watts, which is rated for. I'm not really seeing anything higher. It's kind of averaging around that 51, 52 amp. So I'm going to turn the diesel heater off and that heater and let it cool the van down. And presumably the current will drop as well. As soon as I've turned those off and the temperature sensor is reading the lower mark, it's already starting to drop below the 50 amp. And the temperatures on the outflow are starting to drop to 14 degrees now. Yeah, as soon as the ambient temperature starts to drop, so does the current it's pulling. Right, I'm gonna stop this bit of the video here and let's catch up for the conclusion. I had actually noticed on that last little bit, I had it on normal cooling mode and not turbo, so we put it back on, this time on turbo properly, and just see if we can get it any higher than that 700 we saw. Nah. Well, I can't really get any higher. I'm happy with that. Well, there you go. Power test wise, it said it pulls 700 watts and that's what it pulled. I couldn't really find much difference between normal cooling mode and turbo. Maybe there is, but they both seem to perform the same. Sleep mode was the lowest power draw, and when you put it on the lowest fan speed is also the quietest overall. And the eco mode, again, one of the lower power setting, and if you adjust the fan speed, it's a lot quieter. To get that full 700 watt, I had to get this van 40 plus degrees inside to actually get it, which 700 watt is going to be quite a big power drain. But most of the testing, just using a normal cooling mode and cooling it from 24, 25 degrees, down to about 20, it was only consuming around 350 to 400 watts. And that's actually pretty manageable, even for my van to be producing in good sunlight more solar. So running in its normal mode, you might actually be able to have more solar coming in than the air conditioning unit is using. As for cooling itself, it didn't get the van icy cold down to 16 degrees, but it did fairly easily get my medium wheelbase Transit down to 19 degrees, which is perfectly lovely inside. Obviously if it's hotter outside, it's going to have to work a bit harder. The form factor, being an underbench unit, Retrofitting is probably not going to be the easiest thing, or drilling the holes for the vents, so you would probably have to build your van around that unit opposed to retrofitting it. But it does give you the advantage over a roof-based air conditioner. You can then have space for having solar to actually run it. And that's about it. If you want to find out more about the VELIT 2000U underbench aircon unit, coming in 12, 24 or 48 volt, check out the VELIT website. There'll be links in the description below and a discount code if I've got one. But I hope you like this little tech review. And if you see more tech reviews for different bits of kit to go in vans and overland vehicles, check that out as well. Or check out some of my Arctic stuff. But overall, I just want to make content for you guys to enjoy. So thank you very much for joining me. Consider subscribing if you've liked this sort of content. If you've got aircon in your van or vehicle's habitation area, I'd like to know what you've got, how well you worked and how much power you find it uses. And particularly if you find your solar can be bringing in more than the aircon units are using. But generally, I just want to make content for you guys to enjoy. Anyway, thanks for joining me. Cheers. Bye.